Hey everybody, today we are going to start section 5.8, which is titled the Rational Zero Theorem. However, Mrs. Connors and I decided to focus on what's called the corollary to the Rational Zero Theorem, which I'll talk about in a moment. But what we're going to be doing today is we're going to be learning how to identify possible rational zeros of a polynomial function. Remember, rational means rational, we're talking about any number that can be expressed as a fraction. And the zero of a function is the x-intercept in this context. The second objective is once we've done that, we're going to determine or find all of the zeros of a polynomial function. And today, our focus is going to be just functions with rational zeros, numbers like 2, numbers like -1/2, and so on. So quickly, I'm going to read this thing, the corollary to the rational zero theorem. If a function p of x is a polynomial function with integral coefficients, a leading coefficient of 1, and a non-zero constant term, then any rational zero of p of x must be factors of the constant term. That is one of those things that sounds way more intimidating than it actually is. All right. So essentially, okay, what that thing says is that if you have a function where its leading coefficient is 1 and the constant term is non-zero, any rational zero has to be a factor of the constant term. And so all we're going to do here are list the possible rational zeros of this function. The way we're going to do that is by listing the possible factors of our constant term. So 1, both positive and -1 are factors of 12. Positive and -2 are factors of 12. Positive and -3 are factors of 12. And I'm just going to list the rest of the possible or the factors of 12. So these numbers right here are the possible zeros of this function, meaning if we were to graph this function, it would have to cross the x-axis somewhere at these values. Not all of them, because we're dealing with a cubic function, meaning at most the thing is going to go through the x-axis 3 times. So when we're asked to list the possible rational zeros of each function, all we're doing are listing the factors of our constant term. So just to do that one more time, the possible factors, rather the possible zeros or rational zeros of this function are simply going to be the factors of that constant term, which in this particular example is 24. And so all I did was I listed all of the positive and negative factors of 24. And once again, if we were to graph this thing, where this function would cross the x-axis would have to occur at some of those values. All right, that is literally it. That is all we are asking you to do on this particular example. Moving on. The next thing that we're going to be asked to do is to move from listing what the possible rational zeros are, and we're going to move from that to then find what those rational zeros actually are. So we're shifting from what are the possible zeros to what actually are the zeros of this function, okay? And so fortunately for us, this is a pretty straightforward process, and we're going to do the first thing. The first thing that we're going to do is what we just did. So the first step is we're going to look at our function, and we are going to list the factors of the number -10. So we have positive -1, positive or -2, positive or -5, and positive or -10. So those are the possible rational zeros or x-intercepts of this function. Step 2, I want you to go to Desmos, input this function, and identify the zeros or x-intercepts of this function. So why don't you pause the video and graph that function and figure out where the function crosses the x-axis. Once you've done that, you'll notice that the function crosses the x-axis at 2, -5, and -1. And we've now answered the question by determining what the rational zeros of that function are. Just to do one more example here, we're being asked to take this function f of x and find all of the rational zeros, or all of the places where this function crosses the x-axis. So our first step is we are going to list the possible rational zeros of the function. We're going to do that by listing all of the possible factors of 12. So we have positive or -1, positive -2, and so on. Now we know these are the possible places where this function should cross the x-axis. Now, what's nice about this is that if we, for example, graph our function and we see that the graph crosses the x-axis at 5, right? 5 is not on this list here, so we know that there would be a mistake in terms of how we graphed that function. Now, what I would like you to do now is I'd like you to pause the video, and I'd like you to graph this function on Desmos at desmos.com and identify where that function crosses the x-axis. Now, it's worth mentioning, right, because this thing is of degree 4, we should expect there to be up to 4 zeros or 4 places where the function crosses the x-axis. Now that you've done that and graphed your function on Desmos, hopefully you also saw that the function crossed the x-axis at 1, that the function crossed the x-axis at -2, at -1, and at +6. That's it for now. Tomorrow's lesson, or the next lesson, we are going to be dealing with a slightly more complex version of this question here, where we're going to step away from dealing with functions that just have rational zeros, but we'll be dealing with functions that have rational zeros, but also have complex zeros, meaning that we're going to be dealing with imaginary numbers and things like that. Thanks for watching, and I'll see you soon.